Hello children, myself I.C.Baleechwal welcomes all of you. Today we are continuing chapter 6, squares and square roots. Now today we are learning some special techniques or characteristic of square numbers. Adding odd numbers. Okay. Here, this is 1 odd number. A square of 1 is 1. Now, 1 plus 3, sum of first two odd number. Here, 1 and 3 are the first two odd number and sum of that are 4 and square of 2 is also 4. Okay. Now 1 plus 3 plus 5. Sum of first three odd numbers is 9 and square of 3 is also 9. One plus 3 plus 5 plus 7. Sum of first four odd numbers is 16 and square of 4 is also 16. Now 1 plus 3 plus 5 plus 7 plus 9. These are 5 odd numbers. So sum of 5 odd numbers 25. Here square of 5 is 25. Remember here these odd numbers are consecutive odd numbers. There is no gap in between them. If we start from 1 and we just count the odd number available and just make the square of counting. Here 1, 2, 3, 4, 5. So 5 square is 25. Here 1, 2, 3, 4. 4 square is 16. 1, 3, 5. There is 3. So 3 square is 9. But remember the sum of these odd numbers is also same. 1 plus 3, 4. 4 plus 5, 9. And here is the square of 3 is 9. Means when we add odd numbers, so no need to add them, just count them and make the square of counting. We get directly the square. Okay. And the sum of these odd number is just equal to the square of that counting. So this way we can find sum of consecutive odd number starting from 1 and then onward. Okay. Now we check 1, 2, 3, 4, 5, 6. So 6 square 36. And here 11 plus 9, 20 plus 7, 27 plus 5, 32 plus 3, 35 plus 1, 36. So okay. So sum of these odd numbers is just equal to the counting of these odd numbers square. So this way we can add odd numbers. Sum of first n odd natural numbers is n square. Here n is the number of odd numbers. Okay, remember this thing. This is our conclusion. If the number is a square number, it has to be the sum of successive odd numbers starting from 1. This thing we can remember like this, that if the number is a square number, for example, here 6 is the square number, so it has to be the sum of successive odd number starting from 1. Okay, so this thing is also applicable. If a natural number cannot be expressed as a sum of successive odd natural number starting with 1, then it is not a perfect square. So this thing is also remember what? If a natural number cannot be expressed as a sum of successive odd natural numbers starting with 1, then it is not a perfect square. Okay, so remember this thing. Now sum of consecutive natural numbers. Here is the square of 3, 9, but sum of 4 and 5. 4 and 5 are consecutive natural number. Okay, and sum of that is equal to the square of this. Again we take 5 square 25, but this 25 is just equal to 12 plus 13, and here 12 and 13 is the consecutive natural numbers. How we found these natural numbers? Okay, this is the formula. Here n square minus 1 by 2 and n square plus 1 by 2, where n equals this natural number. Okay, so square of this natural number we can calculate by adding these two numbers. And how we found these two numbers? We found these two numbers by this formula. Okay, now we check 7 square 49, but when we put 7 here, 7 square 49 minus 1 48, 48 by 2 24, here is the 24. 7 square 49, 49 plus 1 50, 50 by 2 25, here is the 25. So we have to put the value of n here and solve this, we get the numbers. Okay, so this way we can found a square of 9 81, and by putting the value of 9 here we get 40 and 41. Okay, so this rule is applicable here. 11 square 121, but 60 plus 61 is 121, which is the sum of two consecutive numbers just equal to the square of natural number. Okay, so this is true. Product of two consecutive even or odd natural numbers. Here 11 and 13 are two natural numbers, and the multiplication of these are 143. But here we can check a number, even number in between the two odd number. We make the square of that, and minus 1 is just equal to this. So here 11 and 13 is just equal to square of 12 minus 1. So this is the relation in between the consecutive even or odd numbers. Okay, so how this comes? 11 into 13. 11 can be written as 12 minus 1, and 13 can be written as 12 plus 1. So here, if we assume this as A and this as B, so A, B, this is A minus B, this is A plus B, so we can apply this identity A square minus B square equals A plus B into A minus B. With the help of this, we can get this. So this becomes 12 square minus 1 square. Okay, so this way we can make this. Okay, similarly 13 and 15 can be written as 14 minus 1, 14 plus 1, so this becomes as 14 square minus 1. So this way we can also found the product of these two numbers. 29 into 31. 29 can be written as 30 minus 1. 31 can be written as 30 plus 1. So the product of these two, that is A minus B, A plus B. So this becomes A square plus B square, A square minus B square. So here is the A. So A square is 30 and B square is 1. So directly we get the value. Okay. So this way we can found the value. In general, we can write any number like this. a plus 1 into a minus 1. That is a square minus 1. Okay. So this way we can found the product of two numbers. Some more patterns in square numbers. We observe some squares. 1 square is 1, 11 square is 121, 111 square is 12321. Here we observe that there is a pattern. How many are the numbers? 1. So here is the 1. Here two numbers, so start with 2 and make the descending order both the side. Left side and right side, 2 and 1, 2 and 1. Here there are 3 numbers, square of 3 numbers. So start with 3, 2, 1, 3, 2, 1, both the side. Here there are 4, 1. So start with 4, 3, 2, 1, 4, 3, 2, 1. So this is a pyramid formed by this. Here there are 5, 1. So start with 5, 4, 3, 2, 1, 5, 4, 3, 2, 1. So we check one more. Here 8 times 1. 1, 2, 3, 4, 5, 6, 7, 8. So square of this, start with 8. 7, 6, 5, 4, 3, 2, 1. 8, 7, 6, 5, 4, 3, 2, 1. So this way the pattern of the square of these numbers is follow. Okay. So remember some interesting things. Another interesting pattern is 7 square, it's 49. 67 square, 4489. Look here, 6 and 7, 13. When we add 13, 3 plus 1, 4. So here is the number 2 times 4. Because there is total 2 numbers, so 2 times 4 and 8, 9. Because sum of this 4, 8 and 9. Because the square of 7 contains this unit digit 9. Now here 6, 7. So here total numbers are 3, so 3 times 4 and 2 times 6. So here 2 times 8 and 9. Now here 3 times 6 and total numbers are 4, so 4 times 4 and 3 times 8, 9. So this is a pattern. Now we check again. 1, 2, 3, 4, 5. 5 numbers, so 5 times 4 and there are 4 times 6, so 4 times 8. This is a pattern followed by these numbers. Okay. Now we solve question of exercise 6.1. Okay. I will solve some questions. By observing them and learning them, you can solve rest of the questions. This is your homework. Okay. Here is the question 1. What will be the unit digit of the squares of the following numbers? Okay. This is the question 799. So without multiplying, we have to found. Here 799 having the unit digit 9 contains its units place digit 9. So square of 9 is 81. Hence unit digit of square of 799 is also 1. Okay. So we can check only the last digit, that is the unit digit, and make the square of that unit digit. Then we get the number. So unit digit of this number is also the unit digit of square of this number. So this way we can directly found. Now we take one more example. This is the question 1, fourth part. 26387. Here contains, this number contains its unit place digit is 7. Okay. So square of 7 is 49. Hence unit digit of square of this is 9. So this way we can found the unit digit of the given number square. Now second question. The following numbers are obviously not perfect square. Give reason. Here we observe the number and explain it. What is the reason that they are not perfect square? Here 1057. Since perfect square number contains their units place digit 1, 4, 6, 9 and even numbers of 0. Okay, but here the unit digit of this number is 7. Therefore 1057 is not a perfect square because its unit place digit is 7 and here there is no 7. 1, 4, 6, 9 and even number of 0. When any number ending with the digits, then that number is a perfect square, otherwise not. Now we take one more example. 64000. Here by observing we can check that 0, this is the pair of 0, but this 0 is alone. So the number of zeros are not in even number. Since perfect square number contains their ends even number of zeros, therefore 64000 is not a perfect square because its unit place digit is single 0. This is a pair and the remain is single 0. So this is not a perfect square. So this way we can found. Now question number 4. Observe the pattern and find the missing digits. Here is the pattern: 11 square, 121, 101 square, 10201, 1001 square, 1002, 001. By observing this pattern we can found here there is 2 numbers. So in the middle there is 2. Here in between these 1 there is 1 0. So in between 1 and 2 there is 1 1 0 both the side. Here there is 2 0. So in between 1 and 2 there is 2 0 here and 2 0 here. Left and right both the sides there is a 2 0. Here the number of zeros are 4. So here 4 0 on left side and 4 0 on right side, and in center there is 2 because 1 plus 1 2. Now here 6 zeros are there, so we put just 6 0 left side and 6 0 right side, and central we put 2. So this way we can fill the missing terms, okay, by observing the given pattern. So remember this type of pattern, first you understand, then fill the gap. Here other type of pattern, question 6. 1 square plus 2 square plus 2 square equals to 3. Here by observing we can found 1 and 2. By multiplying 1 and 2 we get 2. So here is the square of 2. And here one more of that. So there is 3 square. 2 into 3 is 6. So here is the 6 square, and one more of 6 is 7. So here is the 7 square. So this pattern is like that. First 2 numbers multiplying, then we get the third number square. Okay, by multiplying these 2 numbers we get the third number, and by increasing 1 we get the other side. Now we check again. 3 into 4 12. So here 12, and one more of 12 is 13. So here 13. So this way we study this pattern. Now we fill in the blanks. Here this is the missing term, and we have fill it by 20 because 4 into 5 is 20, and one more of 20 is 21. So here is the 20. Either you subtract one number here, but you have to check the multiplication of these numbers. Now here 5 square, and this is the missing term, but Here we can check 5 into 6 is 30 and 1 less of the 31 is 30. So we put here 6 because 30 by 5 is 6. Okay. And now we check the pattern. 5 into 6 is 30 and 30 plus 1 is 31. So this is the perfect pattern. So this way we can fill this type of missing term. 6 into 7, 42 and one more of 42 is 43. So this is our pattern. So this way you can fill the pattern. Now our question, without adding, find the sum. Previously we learned when there is an odd number, consecutive odd number, so no need to add them, just count them. Here 1, 2, 3, 4, 5. So square of 5 is 25. Here there are 5 odd numbers, therefore square of 5 is 25. Here we count the number 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So square of 10 is 100. So sum of these numbers is 100. So this way we can count the numbers. Here there are 10 odd numbers, therefore square of 10 is 100. So this way you can solve the question of exercise 6.1. This is your homework and send me a snapshot of your homework. I will check them randomly. Okay? Have a nice day. Thanks.